This is the fourth lecture in our series from chapter 12, and we're going to move our way through the rest of the fossil fuels. This one is on oil. Oil is also known as petroleum, so you might hear both words used in class or on the AP test. Now first let's talk about how oil is extracted and processed. So petroleum, or crude oil, gets pumped out of the ground using drills, and they usually dig a very deep well that'll go either down to the bottom of the ground, like down to wherever the oil deposit is, or they can also make wells now that are offshore and in the continental shelf, and so they go down through the ocean and then down into the seafloor below. Once the crude oil is pumped out, it's refined to separate the components into different weights. So this is a separation by density. The heavier components of the crude oil sink to the bottom, and the lighter components rise to the top. The way that this is, the reason that this works is because we have differences in boiling points. And so the lighter things boil at a lower temperature, and then heavier things boil at a higher temperature. Now the products that we can make from crude oil range from everything from diesel to asphalt to gasoline. And if you look at the figure over on the right there, you should be able to see most of the figure. I know a little bit is cut off at the bottom of the screen, but basically on the very lightest components, when you heat the crude oil in the tall furnace, or the stack, the lightest components are the gases, and those come off the top. And that would be things like natural gas, like methane and ethane, and propane and butane, which we'll talk about in our next lecture. And then after that comes gasoline, which is what we burn in our cars. Below that is jet fuel or aviation fuel. And then we move into the oils. There's heating oil for homes, diesel oil for trucks. And then the things that are much heavier are things like the grease, the wax, the naphtha, the asphalt. All of those things are components that are collected and saved and used for other products. And somewhere in there too are the different things that we can use to make plastics. So that's one thing that not everyone knows, but plastics come from petroleum as well. And most oil production comes from the Middle East, although in the United States we get our oil from a variety of sources. So oil is refined according to A, the density of its components, B, the pH of its components, or C, the water content of its components. Go ahead and pause. When you know your answer, you can unpause. The correct answer is A, the density of its components. And they use boiling point as their way of separating things out. Now here's a picture that shows an underground deposit of oil and how this sort of thing might form. So basically, oil is believed to have formed millions of years ago when dead plants and animals were trapped in underneath layers of sediment. So they may have died when the ocean flooded or from a comet or something, but however they died, a layer of sediment came over the top, and then through pressure and heat and decomposition, over time, instead of decomposing completely into carbon dioxide, these animal and plant tissues decomposed and formed oil. Now, the lighter components of oil naturally rise to the surface, and that would be the natural gas that's right off the top. And then you can see here we have a shale source rock and a shale cap rock. Basically, the shale is impermeable to the oil, so the oil deposits would tend to get trapped between two layers of shale. So what scientists have to do or geologists, is they go and they look for areas where we have the right kind of rock to act as a cap rock. Then they can drill down through the cap rock and into the oil reservoir, because the oil is trying to rise to the surface, but it's prevented by that shale cap rock. So when the oil rig drills down in, the first thing they pull off is natural gas. It used to be they would just burn it as waste, but now they collect it, and if they can, they collect it and they sell that as well as a product. Below that is the oil, and what they'll do is they'll just pump and pump and pump until they pump all the oil out, typically. Then when the well dries up, they will take it and they'll close up the well and move on to another location. Now, let's talk a little bit about our world reserves. So currently, 65% of the reserves are found in the Middle East. The graph here shows you proven oil reserves at the end of 2003. So this is a little bit old, about 10 years old on this data. But at the end of 2003, we had 726,000 million barrels in the Middle East, compared to the highest other number would be Europe and Eurasia with 105,000 million barrels. So it's pretty intense, the difference there between Middle East and the rest of the world. Looks like we have a 50-year supply of oil if we just look at proven reserves. The Arctic Circle is estimated to hold about 13% of undiscovered oil, so there may be more up there. We just don't know that it's there. Right now it's covered in a lot of water and ice. And 84% of the undiscovered oil is estimated to occur offshore. So that would be in the continental shelf or the deep ocean. And underneath the ocean, and then also underneath the sediment at the bottom of the ocean floor. Now it's kind of interesting to talk about undiscovered oil and estimating how much occurs where, but it does seem like there are large amounts of oil deposits offshore that we haven't discovered yet. And I just want to draw your attention there to that number in case you didn't notice on the bar graph. There are 6 bars on the graph, and if you move your way all the way across, the 6th one is the Middle East, and it's pretty clear that the amount of oil found in the Middle East far exceeds the amount found anywhere else in the world. All right, so let's talk about advantages of oil. First of all, there's a high net energy yield for oil. That means that we get a lot of energy out for every calorie of energy we spend on extraction and processing. Oil is a very well-developed technology. We use it for a lot of different things. The infrastructure is already in place to transport it and to process it and refine it. So we don't need to develop new infrastructure. Like, we already have the oil refinery plants, we already have the tankers, we already have actual gasoline pipelines that run all around the world. The United States has a particularly good infrastructure for pipelines, and they are able to pipe gasoline from one refinery to another, where they're able to do distribution from those places to the trucks. So it's a pretty good infrastructure. Oil is fairly easy to transport. It's a liquid, so not quite as easy as coal. You have to make sure it's in a sealed container, but definitely easier than trying to transport natural gas, which we'll talk about in our next lecture. Also, we have subsidies in the United States to help keep the price of oil low. That means that the government uses taxpayer dollars to pay oil refineries and oil companies, oil extraction facilities, in order to help offset some of their costs so that they don't pass those prices on to consumers. Now, some of the disadvantages to oil, prices in the world are increasing, partially because of our decreasing supply of oil, partially because we're moving to some other technologies that yield oil from different kinds of formations, and partially because anytime we have instability in the Middle East, people kind of freak out about whether the oil supply is going to dry up. So prices are increasing steadily. They go back and forth. Oil also produces some air pollution when it's combusted, when it's burned. So that would be things like sulfur dioxide, nitrogen oxides, and carbon dioxide. And then probably one of the larger environmental concerns is that oil spills in drilling and transportation have the potential to damage wildlife habitats. So the picture there is of the Gulf oil spill that happened. I don't know if you guys remember that. Happened a couple years ago in the Gulf of Mexico. And there was an oil rig that the tube that was connecting to the drill site at the bottom of the ocean snapped and blew off. The cap blew off, and so oil from underground was spewing out into the Gulf of Mexico. And another consequence of that was that the oil rig that was doing the drilling, the Deepwater Horizon, actually exploded and then caught fire and then fell into the ocean. And 11 people were killed in that accident. So that was pretty tragic, made a lot of people reconsider offshore drilling. Some places like California, they decided that they were going to restrict offshore drilling even more. Florida's considering it. It's just, it's pretty dangerous, although even though we know that there's a lot of oil hidden offshore, buried offshore, it's dangerous trying to get it, and we're still trying to understand the environmental consequences. Now, oil drilling itself has a very small environmental footprint because unlike strip mining, all you do is you just stick a hole in the ground. So strip mining, you got to clear everything out of the way. Oil drilling you can do with a very small surface footprint, but the problem is if there is any leakage, if there is any spilling, that can really impact the local habitat. All right, so all of the following are advantages of oil as a fuel, except A, it has a high net energy yield, B, it's easy to transport, C, we have a well-developed infrastructure, and D, we have a reliable supply for our future needs. So go ahead and think about that. Pause if you need to. And the correct answer is D. We do have high net energy yield, easy to transport, and well-developed infrastructure. We do not have a reliable supply for our future needs. Like I said, the present supply of oil is expected to last about 50 years. That's not really long enough to guarantee a secure future, especially if oil consumption increases. All right, and our final thing we're going to talk about is some alternatives to oil. Now, we have this word called synfuels, which is short for synthetic fuels. And this refers to any liquid fuel that can replace oil, basically. So this could be, there are ways of turning coal into a liquid. You can turn natural gas into a liquid. You can get liquid fuels from biomass. So this could be like ethanol or biodiesel. You can also get liquid fuels from things that are very similar to fossil fuels, which would be oil, shale, and tar sand, which I'll talk about in a minute. We can use waste plastics and break those down into liquids, or we can do fermentation process, which is where we get the ethanol. Now, tar sands, there's two kinds of fossil fuels that we are beginning to exploit more now because the standard supply of oil is beginning to decline. So tar sands are one of them. Tar sands are basically what they sound like. It's a bunch of sand that contains tar. So they contain a form of oil called bitumen. Now, the good news is that this makes up about 2/3 of our oil reserves, and it can pretty easily be converted to oil. However, on the negative side, it requires strip mining to be able to access the fuel. So you have to actually strip off all of the land and then strip out the tar and the sand mixed together. There tends to be a high sulfur content, so we run into the problems of having to control for the sulfur pollution, making sure that that isn't released into the atmosphere when we burn the bitumen. And then because of how much processing is required to remove the sand from the bitumen, it has a much lower net energy yield. So it works as a fuel, but it's not the best option. Another option that we have is something called oil shale. Now, oil shale is where you have a shale deposit, which is layers of rock. And this oil shale, in between the different layers of rock, contains a different compound called kerogen. Now, kerogen can be heated up and will become oil. So on the bright side, we have about 3 trillion barrels of oil available in oil shale. But on the negative side, we have some major environmental problems associated with the extraction because we have to crack into these shale deposits. And then we have the standard fossil fuel problems like burning it creates air pollution such as sulfur dioxide, nitrogen oxides, and then the sulfur dioxide can lead to acid rain. So there is no best option. Right now, a lot of our oil comes from Canada, and Canada has some very large oil shale and tar sand deposits. So a lot of the oil that we get in the United States right now is coming from processing that's going on up there. So that is, I think, all we have for the day. If you guys have any questions, feel free to ask. Take good notes. Make sure you turn them in and study for the quiz. And I will see you all in class.